Hi there, this is the exercise 9c. We're looking at converting between Cartesian and polar forms of the same equation. So you might get an equation saying y equals x squared, and you might be able to write that as a polar equation, and you might get a polar equation like r equals 2 cos theta, and you might want to write that as a Cartesian equation. So we have to be able to do this in both directions. So hopefully we'll be able to do that after this lesson. The little starter, first of all, express sine squared and cos squared in terms of cos 2x. Now you should recall there is a formula that says cos 2x equals, well, there's three versions actually. There's cos squared x minus sine squared x. The second one is that cos 2x is 2 cos squared x minus 1. And the third version is that cos 2x is 1 minus 2 sine squared. I have to write over this little polar bear. But either way, these second two allows us to write these in a different way. So you can clearly see that 2 cos squared x equals, effectively it moves over, it becomes a 1 plus cos 2x. And if I divide everything by 2, I get something like that. Or alternatively, I can write 2 sine squared x as 1 minus, these basically swap places, a cos 2x. So therefore, if I divide everything by 2, I get that. And you're meant to know those two versions. Mine broadly are the same as that. I think mine are written slightly better because they're easier to understand if you've got the half at the front and it's plus a half cos 2x, or a half at the front minus half cos 2x. I think it's slightly better. So anyway, we saw I think it was in the very first lesson on polar coordinates, that these three formulas are important. So just bear these in mind. We're going to use these lots and lots today. So write them down if you've forgotten them. But we're going to use these three it's like relationships between x, y, and r and theta quite a lot. So here's my first example. It says points P and Q of polar coordinates 4, 3. So I suppose I'm thinking immediately I'm going to draw this. Pi by 3 is 60 degrees and it's a distance of 4. So I'm going to pretend that's there. That's my P. And the other one's it's a shorter distance away, so this is 4. But it's at a different angle as well. It's 7 pi by 6. Now 6 pi by 6 is a full pi, so it must go somewhere like over there. Not exactly sure, but something like that. And that is, as I say, that's just 1 pi by 6, that angle, whereas that's pi by 3. Then it says, show the points P and Q on the same diagram. I've done that. Find the coordinates in Cartesian form of P and Q. Well, it's relatively straightforward. Now, you can use your calculator to cheat a little bit, but you can also do this using these equations. So I know, for instance, that for this point, that's r, that's theta. So I can quite simply say x equals 4 cos pi by 3. And y, and this of course is for the p, and y equals 4 sine pi by 3. Now pi by 3, if I cos it, is a half, so I reckon that's 2. And this must be, this is root 3 over 2, so this must be 4 root 3 over 2, or 2 root 3. So I reckon I've got the coordinates for p, and now I just need to put coordinates for q. So again, x equals 2 lots. Now I've got to be a little bit careful because this isn't in this first quadrant made it dead easy. I didn't have to think about where it was. I'll have to think a lot more carefully this time. I'm going to do the same thing initially. I'm going to work out how far it moves, but I'll then have to adjust it. So it says r cos theta. So if I type in r cos, now I'm going to first of all just use my brain, and I'm then going to go back and think about it more carefully. This angle here, as I said to you, is pi by 6. So I'm going to use 2 cos pi by 6 rather than 7 pi by 6. So I'll just get my calculator out now and make sure I'm in degrees. Yes, I am. 2 times the cos, in brackets, pi divided by 6. And I get root 3. Now, the reason why I say I'm going to use my brain here a little bit is because it obviously isn't root 3. This is a negative coordinate. So that's where you have to go, it's a negative answer, minus root 3. And if I do the same with the y, now the y is, again, this distance underneath. So it's a negative number as well. So it will be negative minus 2 sine pi by 6. So if I do that, negative 2 times by the sine of pi divided by 6, and pi divided by 6 is 30 degrees, so it's no great surprise that this is minus a half. Minus 1, sorry. Now notice, if I had not done that, 2 cos, and if I just use 7 pi by 6, so I hadn't thought about it, let's see if you get the same thing. 2 times by cos, and in bracket 7 pi divided by 6, close bracket. That has given me minus root 3, so that's worked. And if I'd done 2 sine 7 pi by 6, now notice on these, I'm not worried about changing it, I'm just typing it straight in. 2 times by, what is it, the sine of 7 pi divided by 6. And that is minus 1 as well. So actually both methods worked. I'm sometimes a little unsure about this second method as to whether it has always worked. I'll check it and play around with it and see what you think. I quite like this because I know it will always work. Anyway, what do I then need to do? Find the polar coordinates. Now this is the other way around. So they give me a point. So they say to me a equals minus 3, 5. And I'm meant to convert it. And again, I suppose this is my x and this is my y. And so this is really two pairs of simultaneous equations. I now know that 3 equals 5 cos theta. Is that right? No, I don't. R cos theta. I don't know why I've put the 5 in there. And I know that 5 equals r sine theta. Now, the reason why this is important is because if I do the sine over the cos, you get tan. So sine theta, well, technically r sine theta over r cos theta. The r's cancel, sine over cos is tan, and you'll notice tan theta then is 5/3. And 5/3, if I inverse tan 5/3, it's 1.03. It's not very nice. 1.03 radians. But I suppose the nice thing is it's relatively easy to find. Now there is a simpler way of doing these conversions, but you might not get exact answers. And in a lesson I will show you how to do that on your calculators. The calculator does have a button. In fact, on these Casio ones, it's usually called above the plus and the minus buttons. You often get one saying pole and one saying rec, where you can work out for yourself what that is. And then the second thing I need to, I've worked out theta, I now need my r, I just sub that into here. So if you like, my r is 5 divided by the sine of 1.03. And I know it's positive because it's in the right quadrant, so I'm going to do 5 divided by the sine of 1.03, and I get 5.83. And I'd quite like you to try to do that for the other point. Oh, I just realised this is minus 3. That's bad. But all it does is it means I get minus 3 there, which will give me minus 1.03. But of course then it gives me minus 1.03 here as well. So let's see if that makes a difference. I get minus 5.83. Now you can't get a radius of minus 5.83, so I assume you just ignore it. And what I'd like to do as well, of course, is just highlight to you. I've done one of the points. I'd like you to do B. If I get this first one right, so I've got minus 3 minus root 1. What did I get? Oh, this was for this question up here, wasn't it? Yes, I got that. And 2, 2 root 3, yes, I got that. And on the second one, I got root 34. Now that probably is the 5.83. Now, interestingly, I've lost that. Now you might think to yourself, how come he's lost that? If I do root 34, I get, as a decimal, 5.83. Now how would you do it exactly? Well, it's actually quite easy. All it is really is Pythagoras. And so I could work out r via this other formula. I just realised there's a c appeared here. There shouldn't be a c there. R squared equals x squared plus y squared. And if we use the other formula, you go straight there. So it's just 3 squared plus 5 squared. And you quickly realise that r squared is root 34. And therefore, r squared is 34, and therefore r is root 34. Now, that was much easier than working backwards using the theta, and you're less liable to lose accuracy, if you like. Just see if you can get these two answers for me as well. Are they both positive? I think, Yeah, so one's negative, so just be a little bit careful with that negative. Hopefully you'll get the right answers of Q equals root 17, 6.04. Now we've done quite a lot of time on this, so we need to speed up a bit. The rest we'll do in lesson. So find the polar form of the Cartesian equation y equals x squared. So this is where I'm going to convert from here into here. But the good thing is I know y is, it's r sine theta. So I suppose in my mind I'm thinking r sine theta equals, and I know that x squared is, well, simply r squared cos squared theta. The r's kind of, one cancels out from the other, so I suppose I've now got sine theta equals r cos squared theta, and that allows me to write r on its own with a cos squared theta over the sine. Which way round is it? No, it's the wrong way round, silly boy. So it's the sine theta over the cos squared theta. Now sine over cos is tan, so I can write this as r equals tan theta. Now it's still got a cos on the bottom if I do that, so divided by cos. Now, there's a variety of different ways you can write that. Let's see what mine is. Oh right, yes, that's a better way of writing it, because 1 over cos of course is sec, so that's worked out. A nicer final answer. But I did say there's lots of different ways. Question 2 then. Show that r equals 2a cos theta is an equation of a circle. Now of course, I'll get rid of this again. We have got a polar equation here, and we should know that x squared plus y squared, for instance, equals r squared is one type of circle, but there was also another one, wasn't there? It was x minus a all squared plus y minus b all squared equals r squared. These were both circles that we saw from GCSE and A level. So if we're going to do this, I suppose the big question is how do you do it? And I've kind of written up here, look, we can rearrange this. We can say that x over the r is cos theta. That's one way of getting rid of it. So I'm tempted to do that first actually. If I write r equals 2a, and rather than that cos theta, I'm going to write the x over r. And I suppose straight away you think, hang on a bit, whack the r over there. That gives me r squared equals 2ax. Now of course r squared is, we've got it here, it's x squared plus y squared equals 2ax. And if I move them over to there, I reckon this is a question of completing the square. Now, you may not be convinced, but if I give you an example of what I mean, normally if you try and ask to complete the square, you might have x squared plus 4x. Let's pick different ones, plus 6x plus 10. And to complete the square, what you're meant to do is you go half the 6, so it's x plus 3 squared. But of course, then what you're meant to do is say you get too much. So this is like gives me a plus 9. So I'm meant to subtract the minus 9. Don't forget the plus 10, and I end up with a simplification of x plus 3 all squared plus 1. That's completing the square. Notice the important thing was we halved the number of x's, which we've got here as well. So I can write x minus half of that is ax. So x minus a, I suppose, squared. Don't forget to take away the square of this thing here. So minus an a squared plus a y squared equals 0. Now I can move the a squared over, and I get x minus a all squared plus y squared equals 0. And this is a circle. Now it's actually a nice simple one. It's one of these, but there's no y adjustment. So it's translated a to the right, but it's not translated up and down, so it's on that axis. And it's got a radius of, oh sorry, I wrote that wrong. The a square moves over and becomes an a square. That's better. And therefore that's why the radius is a. And let's see what the posh answers are. Yes, that's what they've got there as well. So then we've got another question which we're not going to get time to do now. This says r squared equals k squared sine 2 theta. Now this makes it a little bit more complicated. We've got a sine theta, we've got a cos theta. I think we might need to use an identity. You might want to have a go at that yourself, but we'll use this as a starting point for our next lesson. So until then, we'll see you. And the next lesson we'll do exercise 9c.